The whole world. Oh, that is so bad. The whole world will know.
3 viewers.
All right. Shh. Thanks, guys. My.
So me and Ali liked your last video.
3 viewers. Wow.
Did you see?
I did. Cause of mean.
I subscribed. You should make some vlogs.
Anyway, I won't do that. All right, let's do this. Thank you. So, last topic for this. The last part of this topic, guys, we're going to build on what we learnt about last lesson. Can anyone remind me what did we learn about in terms of compound interest and geometric sequences last lesson? Yes.
The compound is multiplication.
Good. It involves multiplication. And what's that thing that you're multiplying by?
Geometry.
And it's called the common what?
Ratio.
Good. Okay. And there's two types of common ratios we use. Yeah. Anyone know the difference between these two? Not necessarily takeaway. One's going which direction? Up. Yeah. Which one's that? The green one. Yeah. So this ratio implies that your numbers are going up, which means your numbers are greater than 1. And you got to read the question to see if it's going up or down. And this ratio, if it's going down, use that one. And again, it's working with percentages. Okay? And it's an easy one. Just use the formulas, yeah, depending on what you're working with. Now, here's the thing, yeah. What we've been working with so far is we're working with questions where we're just multiplying once at each year. So each year is basically the next term. So let's say, for example, I started at year 2000. 2001 would be what term? Term 1. 2002 would be term 2. So on and so forth. And that's just once per year. What we're going to look at now is what happens if you have multiple compounds per year. Because what we're looking at, eventually what you'll learn in year 11 is you're looking at investments when you've got, when it says non-annual, annual just means once a year. So if it's non-annual, it means it's not once a year, but it's going to be more than once a year. Okay, that's what that means when we talk about non-annual. More than once per year. All right, and I'll explain what that means as we go through this. But for today, what I'd like you to be able to do, and I think you could probably do half of this already. Can anyone tell me what's the principle? The starting amount. Easy, okay? What's the interest rate? Tell me what is it normally in a question? It's a percentage of some sort. Normally it's calculated per year, but because we're looking at non-annual, it's going to be more than once a year and it's going to change, okay? We're going to look at determining the number of compounding periods. Now, with this part here, it's normally you're looking at the number of times per year if it's more than once. So if I was to ask you guys, let's see, Krish. I said Krish, didn't I? Chris. How many months are in a year?
7.
12. 12, yeah? 12 months in a year. Charlotte, how many weeks are in a year? Lizzie, how many fortnights are in a year? 26, yeah? How many days in a year? Okay, good. How many times, or how many quarters are in a year?
4.
4. How many thirds are in a year? 3. Okay, so all those things, when you're saying those numbers 4, 3, 52, 26, they are what we refer to as compounding periods. Okay? And you know what interest is? It's extra money that you're going to be earning, but you need to calculate how much interest someone earns. And then using recurrence relations, okay, which is something that we've already learned about. So all those things we're going to cover. So the new things is pretty much just this, compound periods. All right. Like I mentioned, when it comes to a question and it's asking you for the compounding periods, I've given you the table here already. You can just refer to this, okay, when you actually work with compound periods. So when we say annually, it's just once per year. If I say 6 monthly, it just means twice per year. Sometimes they use bi-annually, okay? Some of these words are a bit confusing. Quarterly just means quarters, so there's 4 quarters in a year. Bi-monthly means every 2 months, or every 2 months, sorry. Monthly, obviously, 12 months in a year. Fortnight, 26. Weekly, 52. Daily, 365. Now, the reason why this is the case is let's say for example, I asked you, I'm gonna invest some money, and it's compounding monthly. Okay. Yes, Karan. No, no. So, but it's saying every 3 months, which is there's three groups there's 4 groups of 3 months in a year. That's what it's saying. What are you thinking of? Thirdly, that's what that was.
About like every quarter is 3 months, right?
Yes, that's correct. Every quarter is 3 months. And you think about it. Say, Jan, Feb,
Yeah.
March. That's 3 months, and then April, May, June is another 3 months. That's quarterly. But going back to my example, if I told you guys, all right, I've got an I want to put money in an account, and it's compounding monthly. Okay, and I asked you guys, okay, what is the value of my investment after the first six months? Okay, that would technically be the first 6 terms, right? But then what if I asked you, what is my the value of my investment after 1 year? How many terms is that now? If I'm compounding monthly, 12. So you're looking for the 12th term, then, aren't you? Not the first term, the 12th term. If I was to ask you, all right, I'm gonna same thing. It's gonna compound monthly, but I want to know my investment after 2 years. What term am I looking for then after 2 years? Have a think. How many months would that be? 24. So you're looking for the term number 24. Okay? This is where it gets confusing with these questions because you can't treat it as just 1 year equals 1 term. Sometimes each year might have like more than one compound. Okay? All right, now the whole of YouTube is going to hear this. Estevan, you better give that phone to me at the end of class. Otherwise, I'm going to make mum or dad pick it up. Capiche? Yes? Cool. All right, so how do we then make sense of this? Because what you need to do is you still need to find the value of R in these questions. Yeah? Now, there's a slight difference with this. So let's go to the next slide when we're looking for the value of R. Here's a question. Interest rates are based on an entire year, like I mentioned, and therefore your interest is calculated over the year, but sometimes you'll have more than one compound in that year. All right, it could be monthly, it could be weekly, it could be daily. Okay, and that's when you refer to this here. So in this example, you've got 5,000, lovely, and it's invested in a bank account for 6% per annum, but it's being compounded monthly. Okay, so what does this mean, guys? How many times in a year would you compound this? Monthly. Think about it. 12 times. So that means the value of the month for the letter N is 12. So when we use N equals 12, this just tells you number of compounds. Of compounds. That's what N means. Okay, per year. I'll include the number of compounds per year. Okay, just keep that in mind. We're going to include this. So the next thing that you need to do is you need to then use this formula here, where you're looking for R. Okay. Now you've seen this before. It's the increase one, but the only thing we're adding here is we're going to add that divided by N. And again, the reason why is because instead of treating it only once per year, because you're compounding it monthly, you have to divide the rate by 12. If you're compounding daily, you have to divide it by 365. If you're compounding weekly, then it's divided by 52. Okay, so in this question, when we fill this in, what's the percentage rate? Can anyone tell me? Read the question. It's right there. 6%. So it's going to be 6%, but remember, because it's compounding monthly, what's the value of N here? 12. So it's 6 divided by 12. Okay? You don't have to do this step. That's fine, but let's just put it in. 6 divided by 12 is 0.5. So it's going to be 0.5 divided by 12. But just chuck it all in your calculator. So 1 plus 6 divided by 12 over 100. And that will give you the value of R, which is 1.005. So what does this number tell us? Anyone will tell me, Sam, what does this R value tell us? Yeah, that's the number you're going to multiply by to get the next term. That's it. Easy. You've learnt it before. It's just another variation of it. So let's apply this in this example. Okay, state the principal amount A. That's easy. Okay, and then the number of compounding periods. That's also easy. And then calculate the change rate. All right, let me read the question. So in this example, 3,000 is invested at 6 percent per annum. For 2 years, compounded quarterly. Okay, I'm going to highlight the keywords there. You've got 3,000, you've got 6%, you've got the number 2 years, and you've got compounded quarterly. Okay, those are the four bits of information that you're probably going to use for this question. It's already kind of filled out for you there, but the principal amount A is going to be obviously 3,000. Easy. Now, the number of compounding periods. Again, read the question. Compounded quarterly. Again, if you can't remember what that means, just go back to that table. Quarterly, their value is going to be 4. Okay, so that means N will be 4. So in my question, when I actually find my R value, okay, again, you're using that formula here. Just this formula for these sorts of questions. Again, this only applies if you're compounding more than once per year. All right, so in this question, I can see that my percentage rate for the R is going to be 6. So that's going to be 6. And my number of compounds is, I said it was 4. It does say here compounded quarterly as well. So that means my value here is 4. Okay. Again, you don't have to do this, but 6 divided by 4 is 1.5. But just chuck this in your calculator. Oh, sorry, 1. It's 2 divided by 6. 3. I think it's 3. 3. My bad. All right, put that in your calculator. It's going to be. Is it 1.5?
6 divided by 4.
Oh, yeah, sorry. It was 1.5. My bad. So 1 plus the fraction of 6 divided by 4 over 100 equals, okay, 1.015. Okay, 0.15. Okay, write the recurrence relation for this. Okay, recurrence relation. Let me ask. Let's see, where will I ask? Yeah, Celine, can you remind me what's a recurrence relation? What does it tell us? It tells us two things. Yeah, what are they? It tells us two bits of information. The start. Okay, tell me what's the start in this question. Good. Okay, 3,000. And what's the other piece of information it tells us? The common what? The thing you're multiplying by. What's the common ratio here, Celine? Tell me. No, that's the this guy here. That's the common ratio, 1.015. Okay, so this tells you that the starting number is 3,000, and to get the next number, Celine, you're multiplying by 1.015. Okay, easy. Now the next part. Let's go to the next page, guys. Let's work this out. How much money will this guy make after 2 years? Now remember, it's not after 2 terms. Yeah, even though this is 2 years. Okay. Remember, how many times does it compound per year? It's going to be quarterly. That means each year, okay, it's going to compound 4 times, and each of those 4 times is a term as well. Well, in 1 year, how many times are you compounding? 4, yeah? So that means in 1 year, you're given the first 4 terms already. You got to do 8 terms. Because after 2 years, technically that's the 8th term. Okay, this is where these questions get a bit tricky. All right, so T1. How do we get T1? Nice and easy. It's going to be 3,000 times, Celine said the common ratio is 1.015. You can use your calculator. Just go 3,000. Enter. Then you get times 1.015. Okay. First term right there is 3045. Okay, and then for second term, okay, same deal. Multiply it again. It's 3090.68. Oh, this is so small. Okay, next one. Okay, so we know it's going to be 3090.68 times that is 3137.04. So 3137.04. Again, 3184 point. And notice where I'm rounding as well. Here you can just round it, but when you actually do the final answer, that's what I'm really looking for. So 3184.09. So that's 32 31.85. 31.85. Oops. Okay, 3280.33. Okay, 32.33. And I'm just literally repeating the same process until I get to the 8th term. Okay, so this will be 3280.33. Enter 3329.53. So the last one, 3329.53. So after the 8th term, it's 3379.48. Okay, so the total investment amount after the 2 years, which is the 8th term, 3379.48. Cool? Easy? It's basically the same as what you've been doing. Okay, the thing you just got to be mindful of is you can't treat each year as just one term. You have to think about how many compounds per year. Okay? And then that'll tell you what term you're looking for.
What if I asked you like daily?
So if it's daily, that's a big number, isn't it? 365. Okay, so that means you're looking for the 365th term.
Yes, you have to show all your records.
No, do not do that. Okay? Do you guys remember watching the nth term rule video that I recorded? Because I did record that. Okay, you know what? Let's just do that as an example. Yeah? Yeah? Let's do it. You know what? Let me pause my video. And I'm not saying, again, that this is on the SAC, but a lot of the principles that you'll learn here, you will have to apply on your SAC. Yeah? And I think the other classes aren't actually going through this, so don't tell them. All right? Also, this is not real. It's not real, okay?
You are into Bitcoin.
All right, so Mr. Todio is looking to invest $5,000 in digital currency. Ooh, fancy. He's determined, yeah, Lizzie, that his two best options are either going to be Bitcoin or Ethereum. Do you know what that is? I'm sure you all have heard of it before. Yeah. Below are the annual rates, compound period times, and times that he's able to invest for both the digital currencies. So I've done a bit of research. This may not have been the case. This may not be the case now, I think. But these were the numbers at one point in time. So for Bitcoin, you're allowed to invest in it for 6 years. You've got a rate of 6.98 per annum. Okay, so that means per year. And it compounds monthly. Oh, very nice. Okay. Per annum means annually, yeah. That's just a term. That's just a term. For Ethereum, okay, they allow you to invest for 4 years at this rate, and look at that, it's a higher rate, yeah, interestingly. But what's the deal with the compounding? It's less. It's quarterly, not monthly, yeah? All right, so for the first question, here we're asked to find the common ratio for both of them using that formula that we just learnt today. So this, the only thing we've included now is that divided by n, because you're compounding more than once per year. So, where'd it go? It disappeared. Dead haps, DH.
Please be quiet.
It's stuffed up on me. What is this? Yeah, dead happenings. Isn't that what it means? Dead happening. It's like it's not working or it's boring. It's boring. It means it's boring. All right, we're back. Okay. okay. I am FR now. For real?
Oh my god.
All right, I'll stop. All right. So the question is, we need to find the common ratio, guys. So I'll do the Bitcoin in red and then Ethereum in blue. According to this, use the formula. So it's going to be R equals 1 plus. Now, can anyone tell me what's the rate for Bitcoin? Beautiful, 6.98. And how many times is it compounding?
12 times.
12 times because it's monthly. Good, thank you, Karan. No one knew that. Okay, divided by 12. And then divided by 100. So for the common ratio of Bitcoin, okay, let's see how much they actually do. 1 plus 6.98 divided by the 12, and then that divided by 100. So the common ratio is 1.0058. Cool. Cool. 1.0058 for Bitcoin. All right, what about Ethereum? Okay, again, use the same formula. It's going to be R equals 1 plus. What's the rate for Ethereum? 9.98. That's very high. You can't see? The blue? All right. Let's use purple. Is that better? Okay. I think green's a bit too bright. So 9.98, whoops, divided by, again, what's the number of compounds? It says quarterly, 4. Good, you guys get it. Divided by 100. So the R here, let's start again. 1 plus 9.98 divided by 4 divided by 100. And that equals 1.025. Let's just round that to that. 1.025. Okay. Now, here's a question, guys. If I was to ask you, out of these two investments, which one do you think you'll make more money out of? Ethereum or Bitcoin? You reckon Bitcoin? Why Bitcoin, Karan?
Yeah, Bitcoin.
Why Bitcoin?
It's monthly.
It's compounding monthly. You're compounding more often. But if you look at Ethereum, we've got a pretty good rate. It's really.
That's only quarterly.
It is only quarterly. So what we'll see is which one is then better. Okay, we're going to see which one is actually better. So find the value of the investment after 1 year for both currencies. Now, here's the thing, yeah? After 1 year, that means that we're looking for a certain number of terms. If you're looking at Bitcoin, how many times is it compounding in 1 year? 12. So which term are you looking for after 1 year? The 12th term. Okay, so that means you're looking for the 12th number in this. So if you go 5,000, I would say there's a rule that you can use, which is this. So you can use that now, but I'm going to use the calculator here for now. Because this rule tells you how to find high value terms like 365 days, which is annoying. Yeah. Here it's 12, it's not too bad. So that times 1.0058. I'm just going to press enter 12 times. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Fantastic. Okay, so after 1 year, or term number 12, because it's after 1 year, it's 5,359.32 after 12 years. Term number 12. All right, let's try Ethereum, see if it's any better. So we're going to go 5,000. But here's the thing, yeah? How many terms would Ethereum be? Because if you're doing quarterly, good, you're looking for term number 4. Okay, so it's going to be 5,000 times 1.025 4 times. So there's term 1, term 2, term 3, term 4. That gave us 5519.06. Okay, so some of you are saying, I reckon you'll get more money out of Bitcoin. But according to this, after the first year, you've already made a bit more money using Ethereum. But we'll see what happens because you guys are right in thinking the number of compounds does affect it. So this is the one thing that I told you guys that will help. This is the nth term rule for finding high value terms when it comes to working with compound interest. Yeah. If I was to ask you guys, what does V0 mean? Starting, easy. What's the R? Ratio. Yeah, common ratio. What's the T? Have a think. What do you think T might be? Time just in years. Good. And what's N? It's just the number of compounds per year. Okay. So that's all it is. So for this question, we need to make a rule for both of them. So for Bitcoin, okay. Oops. For Bitcoin, sorry. It's going to be, your rule is going to look like this. Tn equals, V0 is the same as for both of them. It's going to be 5,000 times. Now, what was the R for Bitcoin? 1.0058. So we're going to go 1.0058. and then to the power of t. So if you look at this question, what's the time? 6. So t is going to be 6. And then all you got to do is leave n because we don't know what n is for the rule. N is what you'll be changing. Okay, so we'll leave it at that. And then for Ethereum, okay, again, use the same format for the rule. It's going to be Tn equals 5,000 times. The R in Ethereum is 1.025. Okay, to the power of the number of years in Ethereum. According to this, we only have 4 years, so we're going to make that 4. And then the number of compounds is times, well, that's what we'll be looking for, okay? So there's my rule. Yes, you can't see which one. Oh, it's too small, sorry. Should I use it? I'll use a different color. Well, is purple better? How's purple? All right, let me rewrite it, sorry. Sorry. Tn equals 5,000 times 1.025 to the power of 4 times n. Okay, and n is the term we're looking for here. Well, actually, n is the number of compounds. Okay, which isn't too bad. Right, so actually, can everyone see that now? Is that better? I'm gonna leave that there. There's my rule. All right, so for question D, we're going to use our rules now to find the total investment for both currencies and which one would be a better one for me. Now, I haven't made a decision yet on this in the real world, so I'm going to see which one is better. All right, so for Bitcoin, it's going to be 5,000 times 1.0058 to the power of 6 times. Now, what's the number of compounds for this? What does it say? Monthly, yeah? So how much times is that per year? 12. So some of you might actually just be tempted to just go 6 times 12, which is 72. And that's fine. But you can just leave it as 6 times 12 in your calculator. Okay? So let's calculate this. 5,000 times 1.0058 to the power of 6 times 12. And that gives us, good money, $7,582, and I'll round it to 2 cents and 41 cents. Okay, what about Ethereum? Let's see if that goes any better. So it's going to be Tn equals 5,000 times 1.025 to the power of 4 times. Now, remember how many times is it compounding? 4. So quarterly. So what will that give us? 5,000 times 1.025 to the power of 4 times 4. It gives us 7422.53. So I love that you guys understand that because it's compounding more in Bitcoin, you'll probably make more. Over a longer period. Good. So mathematically speaking, which one's a better investment after 5 years? Bitcoin. But if you're only going to invest for 2 years or 1 year, maybe Ethereum is better. So it really depends on what you want to do. So as a suggestion for Torio, I would probably invest my money long-term wise in Bitcoin.
Yeah, but that doesn't have the rates change.
Rates change. Yep, exactly. There's a lot of changes. Sometimes the value of Bitcoin might go down. So who knows? Mom Saul.